Here's an example of a confidence interval. Let's see what it says. A negative ion sports bracelet claims to increase athletic performance. To test the bracelet, 8 runners are asked to run a mile wearing the bracelet. Their times in minutes are compared to their times without using the bracelet shown below. So no bracelet, with bracelet in minutes. So 9 minutes, 9.2. So it looks like this person, this runner, went faster with the no bracelet than he did with the bracelet. So that's not good. He's actually slower with the bracelet. This person, this person did faster time with the bracelet than he did without it. This person did a little faster. This person did a lot faster. This person was slower with the bracelet. This person was slower with the bracelet. No, it took a longer time. This person was faster, a little faster with the bracelet. This person was faster, lower time with the bracelet. All right, anyway, so we're supposed to, notice this is matched pair data. See how it's all matched up? You can tell this is runner number 1. Number 2, right? This is his time with no bracelet. This is his time with the bracelet. This is runner number 2's time without the bracelet and with the bracelet, etc. So that's why these are matched up. This is the same person. This 9 and 9.2 are the same person, so they're matched. It's not like these are just, 1, 2, 3, 4, 5, 6, 7, 8. These are just like 8 runners at random, and these are a different 8 runners. So they could have done the test that way, but that wouldn't be a very good way to test the bracelet, would it? Because well, I just had 8 random runners run with no bracelet, and then a different 8 runners with a bracelet. No, that would be a bad way to test it. That would be independent groups, 2 independent samples, but these are matched pair, dependent samples, meaning dependent samples, meaning these numbers depend on these numbers, right? This 9 is connected to that 9.2, this 7.4 is connected to the 6.8, etc., because they're the same person, with and without the bracelet. That's called match pair data. Whenever we have, somebody before, like a treatment, before and after, like how is this, medication affecting you, before and after. So that's matched pair data. Or if you have couples, how did people feel about, what's their view on a new proposition? And they're married couples, the husband and the wife. That's going to be matched, but they're probably going to think alike. Etc. So that's whenever you see stuff like that, it's matched pair data, when there's a connection between the numbers. There definitely is here because this is the same runner with and without the bracelet in each case. So these data are matched up. We call them dependent samples. Okay, so how do we handle that? Well, if you look at the notes here, I've shown you. So not independent means, see, they're not 2 independent. It's not proportions. It's 2 dependent matched pair means. That's where we're at. We're right here. Data is matched in pairs. Actor, actress, couple, male, female, subject before, after, etc. What do? Well, we're not doing a hypothesis. You got to put the data in L1 and L2. Second L1. So you first got to put the data in L1 and L2. So let's do that. So we got to put the data in L1, L2. So we've got to go stat. And then you're already on edit, so hit enter. Go to the top of L1, hit clear and enter. And then go to the top of L2, also hit clear and enter. So clear out L1 and L2, and then you put L1, you put this data, L2, you put that data. I want to put those at the top, I guess, So L1 will be all these numbers. L2 will be all these numbers. So put the data in L1 and L2. So all these numbers in L1, all these numbers in L2. I'm going to do that also right now. Let's see here. Stat, edit, go up and clear. Clear L1 and L2, and then put the numbers down there. and then over an L2. All right, I've got them in L1 and L2. Now what do we do? So looking right here, it says put the data in L1 and L2, then enter second 1 minus second 2, which will put an L2 on the screen, store, which is second 3, into L3, and the store button is in the lower left corner, right above the on. So that's what I push. So let me write that down here. I'm going to hit second 1. So, well, I should say you have to quit. So after you've got your data, I should probably add that to the list. After you get your data in L1 and L2, I think I'll add that to the note. So put data in L1 and L2. Hit second, quit. The quit button is right above the mode key. Second mode quit, the second mode quit button. So quit out of that table and then hit second 1. When you hit the second button and 1, that'll put L1 right in your screen, and then go minus, and then go second 2, go minus second 2, and that'll put L2. What's showing up on your screen right now is L1 minus L2. And then you're going to push store. That is right above the on key. It's lower left above the on button. It's the button above that. It's STO, store. It means store, hit that. Whoops, I just hit the wrong button. Hit store. And what it does is it shows an arrow. Yeah, it's actually, I should write that a little bit better. It's actually STO arrow. Like that. And so it stores. It means take L1 minus L2 and store it, and then where? Store it where? Hit second 3. That means store it into L3. That's what will show up on your screen. And hit enter. Enter. And what we just did by doing that bunch of buttons right there. Let me get rid of this. What we just did is we just subtracted L1 minus L2 all the way down. Let me write it right here. We just took, these are the L1s, these are the L2s. So we just went like this. 9 minus 9.2, which equals negative 0.2. And we put this into L3. Minus, and whatever that equals, I'm not going to, 0.6, and minus, which equals, I'll write this out, but you don't have to write this out. I'm just showing you what we did. I want you to understand. I'm going to go etc. So these just went into L3. The calculator did it for us automatically. That's what just happened. We had L1 and L2, and we told it take the L1 numbers, take all those L1 numbers, minus all those L2 numbers, and store it into the L3. If you look in your L3 now, you don't have to do it. You'll see all these numbers are now stored in L3. So the differences are now stored in L3. Let me write that. The differences now are stored in L3. We told the calculator to take all the L1 numbers minus all the L2 numbers and store those answers in L3. So it just, if you went back and looked at your edit menu again, all of a sudden you'd see a bunch of new numbers in L3. It just subtracted all the way down that list and put the differences in L3. Now, why does that matter? Well, the differences are what's going to tell us whether the bracelet's working or not, right? Because you see, if the runner did 9 minutes with no bracelet, and then took longer, 9.2 minutes with the bracelet, you got a negative answer. The bracelet didn't work very good. It slowed him down. Whereas the second runner did 7.4 with no bracelet, but then went faster. The run only took him 6.8 minutes when he was with the bracelet. That was a positive difference of 0.6. So the bracelet helped him go faster by 0.6. So all these differences, they tell us if the bracelet helped or not. Positive answers are when the bracelet helped, because with the bracelet, the total was lower. So when you subtracted, you got a positive answer. Negative answers like this one tell us the bracelet did not help that person, they hurt that person. Then when the second number is higher, when the with the bracelet is higher and you subtract, you're going to get a negative, which means the bracelet didn't help. So these differences, whether they're positive or negative, are what's going to tell us whether the bracelet's working or not. So now we're going to tell the calculator to do an analysis on L3 where these differences are stored. How do we do that? Well, look back at the notes. So put data in L1, L2, then enter all that stuff we did. Now go to t-test or t-interval. Which one? Are we doing a hypothesis test? No. We're doing a confidence interval right now. If we were doing a hypothesis test, we would use t-test. If you're doing a confidence interval, you use t-interval. T-interval, data, and then we'll do that. All right, let's do it. So now, coming on down here, we will go. So bring it down here. I'm going to choose stat. Go back to the stat menu like usual. Go over to tests and go down to, what did it say? T-test, right? I'm sorry, t-interval, because we're not doing a hypothesis test. We're doing a confidence interval. T-interval. So go down to t-interval. So go stat, t-interval. Where is that one? It's number 8. And hit enter. All right, when you do, you can choose data, because now we put in data, didn't we? We spent a lot of time putting in data. Highlight data and hit enter. And when you do, you'll see list. That should say L1. Oh, I'm sorry. It does say L1, but you want to change it to say L3. That's very important right there. Change by hitting second and 3. Why? Because that's where our list of data is now, right? The list that we want the calculator to work on and analyze for us is now here in L3, right? That's where all the differences are. We stored them all in L3 when we did these entries here. They're all stored in L3 now. So that's what you want to do. So you have to hit second 3 there when you get down to list. Hit second 3, and it'll pop an L3 in there. All right, and then the rest of the stuff is just normal. Frequency's just 1. Confidence levels, whatever it is. They want it 85%, I guess. 0.85. And then hit enter. The calculator will do it. So that's what these notes are telling you right here. Data, list is L3. It's very important. The list is L3. So did everybody see that? That's super important. The list has got to be L3 when you're doing this kind of problem, because we did all this storing our results in L3. So then when you go to stat, you got to make the list L3 so the calculator analyzes the data in L3. That's where the differences between the L1 and L2 numbers are now sitting in L3. So you tell your calculator to analyze the L3 data, which is the differences between L1 and L2, and you get an answer. And here's what I'm getting. Rounded to 2 places, I'm getting negative 0.11, comma, make that negative a little better here. Negative 0.11, comma 0.41. What does that mean? What does that mean? Well, we got a negative and a positive, didn't we? Well, if you look back at the notes, it'll tell you. If you get two negatives, no. Two positives, no. A negative and a positive, yeah. Some negative, some positive. 0 is included, right? That's true because between negative, so we're getting a confidence interval here. Erase this. Our confidence interval is between negative 0.11 and positive 0.40, meaning we're 85% confident that the real difference between this column and that column, meaning no bracelet and bracelet, the real difference, we're saying we are 85% confident that the real difference is between negative 0.11 and positive 0.41. Well, it turns out that's not saying much because here's 0, right? So it could be negative or it could be positive. You see the problem? When you're saying that you're sure the real answer, that's what a confidence interval is, right? You're sure that the real difference, because that's what we're trying to test out. Does this bracelet really work or not? Well, based on our sample of 8 people, we're doing our best to figure out what the truth is for everybody who will ever use the bracelet. That's what confidence intervals are all about. Trying to estimate from a small sample of 8, 10, 12, 20 people, trying to figure out what the truth is for something forever. So what's the truth of this bracelet forever? Well, we're 85% sure that the real average forever for this bracelet, the difference between no bracelet and bracelet, for athletic performance when they run is going to be between negative 0.11 and positive 0.41, which means it could be negative because there's some numbers below 0, or it could be positive because there's some numbers above 0. So we don't know whether it's negative or positive. We don't really know. So some negative, some positive, which means the difference could be 0. There could be no difference. It implies that the difference might be 0. And if the difference is 0, they might be equal, right? If I subtract two things and the difference is 0, how do you subtract two numbers and get 0? Only if they're the same number, right? So the difference might be 0, right? Because all we know is the difference is somewhere between, it's somewhere in this range between negative 0.11 and positive 0.41. It could be negative, could be positive, could be 0. We don't know. So we have no confidence that they're different. They might be the same. We have no confidence that they're truly different. They might be the same. So this is inconclusive. Right? If that interval had come out both positive, for example, all positive, then that would mean the difference is positive. And how does the difference come positive? Well, the first number's got to be bigger. First number's bigger. If the difference is all negative, then the first number is smaller. But that didn't happen for us. We got a difference with some negative, some positive. That's inconclusive.